Hello and welcome to integration part 3. It's just a follow-up of part 2 to see if you remember a few things. So I have this question is from KMF, but I'm not following what is asked. I have introduced my question to see if you followed the other one, and if you didn't, get it from here. So you have a curve here, this curve. Y is equal to 4 minus x squared. Then I have a line here, y is equal to 3x. In the question, it is shaded like this. I've shaded using red, but in the question, it is like that. So I'm not following exactly what is asked. I want to remind you a few things that I taught, which are very essential. In the previous question, I asked you if you cannot get it direct, what you need to do is to analyze that figure and see what big figure you can get, what small figure you can get, then you subtract. And also there were points of intersection. So like the first question I'm asking you is, how would you get the point of intersection between the curve and the line? The curve and the line meet at point Q and R. Okay? They meet at point Q here and point P. Point of intersection. This is the medicine. Equate the two equations. After making a letter the subject. In the format of calculus, y is normally given as a subject. So from this equation, y is already the subject. From the curve, y is already the subject. Then equate these two. Here I am. 3x is equal to 4 minus x squared. Okay? You equate those two and solve. So when you move on, you will get x is negative 4 and 1. That's not a big deal. So do you remember how to get points of intersection? Second attempt. If I ask you for coordinates of those points, the coordinates of the points P and Q require the second component, which is y coordinate. Already we have x coordinate. Now you are required to get the y coordinate. So since it is a point of intersection, you can take the x values and put them in either of the equation. In this case, this equation is easier to use rather than this. So I take my x found in any of the equation. So use values of x found in any of the equation. So I have x 1 and also x is negative 4. Okay? So in other words, I can put those x's at this point, 1 here, and this is negative 4. Okay? Where they have met. So I want the y coordinate. I put x1 in the equation. I get y is 3 at point P. At point QY, I take 3, this 3 multiplied by the negative 4 that I had found. I get negative 12. So this is the way you finish. If you put is equal sign, you miss the mark for coordinate. Okay? Right. Now I have done up to here. I want us to focus on the lower part. Once in a while, I'll be changing the camera position. So I take you down here. Let us sit down. I think you can see from here up to the end. How do you get intercepts? So I have put, again we go back, check. I've put here as A and this point as B. So those are the x-intercepts I want. Just get the point? Go back. How to get intercept? If I want x-intercept, you put y is equal to 0. So you will reverse this and complete it for yourself. What about if I want y-intercept? Put dash dash is equal to 0. Complete that. We continue because I want x-intercept. Okay? The curve has the equation y is equal to y is equal to, this is the equation of the curve, y is equal to 4 minus x squared. That is the equation of that curve. And you only put y is equal to 0. So in place of this y, I put what? 0. Then you get square root of 4, which can be plus or negative 2. We go back again a bit. That means this point is negative 2, and this point is 2. See, step by step. Now we go back again. I see if we can conclude now. We are somewhere here now. Okay? So I ask you to get the region between the curve, okay? The region between the curve, the x-axis, and the line QN. Again, I take you back. I want this now shaded in 0, 0, 0, 0. This one. That is the region I want now. Between the curve, okay? This is the curve. This is the curve. Then the x-axis. Then the line QN. It is not a triangle because this part is a curve. So what do? Go back. What do we do here? We integrate that curve with the ordinates at -4 and at -2. Okay? We integrate that. So when we integrate this, we get in the square bracket, we get it. I think we can focus better here now. Yes. Can you get it better? More? Think we can get it better when we focus more? Yes, I will put it down. So we integrate this. You can see it. We integrate that. 4 becomes 4x. X squared becomes a third x cubed. Then my limits of integrations are that. When you put inside, you find out that this part becomes -8. Negative cubed will be negative, and with this minus plus that. Then subtract. Now we put the lower limit. -4 by 4, -16. Negative, when it is cubed, it becomes negative, and negative, it becomes plus 64/3. When you compute all this, if you compute all this, you get -32/3. Okay? But the area cannot be negative. So our area will be 10 2/3 square units. Okay? This. So you can take your time and compute this. Because of the writing space, I cannot do everything. We go back. If we can go back a little bit, then you will do this at home. Now, you have known this. Remember, this area also we can get. I can get it as a triangle. 1/2 times base times height. This one, because this is a straight line. If I ask you, now I put this letter O, not 0. OQN is a triangle. So 1/2 base times height. Since from here to here we know, you should be able to handle that. Alternatively, you will integrate. you integrate 3x dx from 0 to -4. From 0 to -4. Okay? That is 3 over 2x squared. 3 over 2x squared. The lower limit is not an issue. 3 over 2x squared. Okay? So if you put here 16, 2 goes into 16 8 times. 8 times 3, 24. Okay? You can get it. Now, I want you as assignment to find out the whole area. We have already found, you can find the area of the triangle, subtract the area in blue, you will get this portion in red here, which will be added to this. So try to integrate this with respect to x from -2 to 0. See if you will get the answer in KMF. Goodbye.